Welcome back and thank you for joining. We'll continue with another example of inverse relations. This time we're looking at a rational or reciprocal function. We have f of x equals 1 over x minus 3 minus 4, and we are inverting it first, so finding the inverse. Remember step number 1, we replace f of x with y. So we have y equals 1 over x minus 3 minus 4. Step 2, we switch x with y. So wherever you see y, you write x, and wherever you see x, you write y. The next step is solving for y. So this is kind of a unique process for rational functions or reciprocal functions, because we haven't typically solved these kind of equations very often. But it's not a difficult process to kind of learn and make your own. So since the variable that we are trying to solve for, the variable y is in this term, we'll try to isolate it first from this number that is subtracted. So that means we have x plus 4 is equal to 1 over y minus 3. So next we are going to, and this is where the process starts becoming a bit different, we're going to write both sides as fractions so that we can see the cross multiplication, how it can happen here. So we have x plus 4 multiplied by, I keep writing y as a number 4 as a y. So x plus 4 times y minus 3 is equal to 1. Now we're trying to isolate y. And y is in this binomial here. So we will have to isolate the binomial first. So which means y minus 3 equals, so think about how you can isolate the binomial from something multiplying it. So you got to divide both sides by x plus 4. So, and that will give us y minus 3 equals 1 over x plus 4. We are very close to completely isolating y, so we're going to take the negative 3 to the other side, and this will change to become 1 over x plus 4 plus 3. So now we're going to give it a name, so we'll call this f negative 1x, that's what it is equal to 1 over x plus 4, and then plus 3 at the end. So we'll try to draw both graphs, the f of x and the graph of f negative 1x on the same coordinate grid. So we're going to make them these two different colors. Now remember that f of x is a reciprocal function, and the horizontal translation will produce a vertical asymptote. So the vertical asymptote, we have discussed this in the second lesson of the unit. So just recall, look at the notes again. So x equals 3 is a vertical asymptote, and the horizontal asymptote will come from the vertical translation, which is 4 down, and that will give y equals negative 4. So as you can see here, the vertical asymptote will come from the horizontal translations. Think of what horizontal translation we have in here. Since you see a plus, it means we have subtracted a negative. So vertical asymptote will be at x equals negative 4, and horizontal asymptote will be at y equals 3. So we're going to start off by drawing the graph of the given function first. So I kind of prepared this one here. Let's see if it's going to work. So we have a vertical asymptote at x equals 3. And the horizontal asymptote is at y equals negative 4. So right here. So as you can see, x equals 3 is the vertical. Y equals negative 4 is the horizontal. This is the reciprocal graph, the parent reciprocal. And be sure to label the asymptotes by their equations. When it comes to graphing reciprocals, this point here is very important. So there is no stretches applied. So this would be 1 unit far from each asymptote. And so is this one here on the other side. Now, next we will be drawing the graph of the other function. Let's make this one green because this is the given function. So give me 1 second here. So let's change the color of it. So there we go. We have the graph of this particular function here. Now we're going to draw the graph of its inverse. Now the inverse has the vertical asymptote at x equals negative 4. So there goes x equals negative 4. The vertical asymptote is at y equals positive 3. So y equals positive 3 will sit right here. Now we're going to draw the graphs of this function. So it's going to be, this one is the important point, right here, nested at the asymptotes. It's not as smooth as I want it to be. There we go. This is going to be one of the arms. And the other arm of, or the other piece, we should say, because reciprocals are piecewise functions. Their domains are broken by their asymptotes. So this would be the graph of f negative 1x. And the vertical asymptote in here would be at x equals negative 4, whereas the horizontal asymptote would be at y equals 3. Notice how the asymptotes have swapped in here, right? The vertical becomes horizontal, horizontal, vertical. All right? So as you can see in here, the graphs look exactly the same, and you can tell that they are reflections of each other about the reflection line, which is at y equals x. So let's draw that line here. And the invariant points will be exactly at the intersection of the function, so the green function in here, and the y equals x. And this is where the inverse intersects as well. So in order to determine the coordinates of the invariant points, we're going to follow, we have two methods we mentioned in the previous videos. So we can start off with a given function first. So it is best to start with given functions for reasons that we've mentioned. It's more accurate, always more accurate, no mistakes made in, creating the equation of it. So we can start off with the equation of the given function, which is 1 over x minus 3 and then minus 4, and replace f of x by x. The reason why we do this is because at the invariant points, the value of x, the values of x and y in the function should be equal, because at the reflection line, x and y are equal. Let's write the equation so we remind ourselves of it. And this is how it works. X minus 3 and then minus 4. So we need to solve this equation. Again, it's not a traditional quadratic equation that we have solved in the past. Not too difficult either. Now, I want us to think this way. So we are trying to solve for x, and we don't want to have x in the denominator because x in the denominator is kind of harder for us to solve. We know how to solve quadratics, right? But no x is in the denominator. So we'll try to bring this negative 4 to the other side first, and that will become a positive. And once we are at this point, so we're going to make the left side into a fraction as well, so that we can see the cross multiplication, so how it can happen in here. So this is what happens. And what we see in here is x plus 4 and x minus 3 multiply to 1 times 1. So expand, so x squared plus 4x minus 3x minus 12 equals 1. Or even better, x squared plus 1x minus 13 equals 0. So obviously this is not factorable, so we're going to ask for help, the quadratic formula. So the value of b is positive 1, so negative 1 plus or minus square root of, and then we go b squared minus 4 times 1 times negative 13 over 2 times 1. So that would be negative 1 plus or minus. Negative 4 times 13 will be a 52, and 1 together, 53 over 2. So we get two x values in this case. We get x at negative 1 plus root 53 over 2. And x equals negative 1 minus root 53 over 2. We're going to leave the coordinates in exact form. And just to clarify, what we just found in here now are the values of x where the given function will intersect the reflection line y equals x, and obviously in the meantime the inverse function. So in other words, we found the x coordinates at invariant points. Since we found two x coordinates, it means that two invariant points exist from reflecting f of x about y equals x, or from inverting it. So the coordinates of the invariant points are two of them. And we just found the x coordinate, which we'll write it down here, -1 plus root of 53 over 2, -1 minus root of 53 over 2. So about the y coordinate, always remember the y coordinate is equal to the x coordinate, so -1 plus root 53 over 2, -1 minus root 53 over 2. So if we were to discuss the question whether or not f-1x is a function or not, we're going to say yes, it is a function because it does pass the vertical line test. I hope this made sense, and thank you for learning with me. Bye for now.